Hello calculus students, we're going to be going over some practice problems for absolute, max, and minimum. Alright, so let's get started. So for number one, not number one, I'm sorry. Number 16, we have y is equal to negative x squared. Let me scoot up a bit. We have negative x squared minus 4x plus 2 at the interval negative 3 comma negative 1. Okay, so first we find the derivative. We get negative 2x minus 4. From here we set it equal to 0, so negative 2x minus 4 is equal to 0. You add 4 to both sides, and we get negative 2x is equal to 4. Negative 2 divided by negative 2, and we get x is equal to negative 2. That is our critical point. So now we draw the graph. We have the interval, we have the numbers, and we have our sign. So from here, we're going to plug in negative 3. Okay, that's the interval that we're looking at. We're not going to look at negative infinity. 2, negative 2, okay, that's where we got one of our critical points, which is between negative 3 and negative 1. So we close it right there, and then we go on the next interval of negative 2 to negative 1. So a number between negative 2 and negative 3 is going to have to be negative 5 over 2, and then this is going to have to be negative 3 over 2. So we're going to plug this into the derivative, and we're going to have negative 2 times negative 5 over 2 minus 4. This is going to turn into 10 over 2 minus 4, and that's going to be 5 minus 4, which is equal to 1. So we have a positive, and then we're going to plug in negative 3 over 2, so that's going to be negative 2 times negative 3 over 2 minus 4. We're going to have 6 over 2 minus 4, and that's going to be 3 minus 4, which is equal to negative 1. So we have a negative. From there, we are going to see that this goes like this. So that means that negative 2 is at a relative max, but we want to know the absolute max and min. Absolute max and min is on any graph. Let me just draw it really quick. I will delete it. But absolute, so if we have here and we have A to B, and we have, let's say, something like this, for example, little circles, a little graph. Okay, that's a bad graph, but this would be our max, and these two would be our absolute minimums. So because this is where the interval that is given, let's say this was negative 3 and this was negative 1, even though it's on the right side, but that doesn't matter. And this was our negative 2. So these 2 points are the lowest of the interval that we are given of the function. So we want to find the absolute minimum, and we want to find the points for it. So now we're going to get our critical numbers, which are, so we're going to get f of negative 3, and then we're going to get f of negative 2, and we're going to get f of negative 1. So f of negative 3, that's going to be, we're going to have negative and then 9 plus 12 plus 2, that's going to be 14 minus 9. That is going to be 5. Negative 3 is equal to 5. Negative 2, we plug in negative 2, that would be negative and then 4. and then that would be plus 8 plus 2, and we would get a negative 6, no, sorry, positive 6, and we plug in negative 1, we would get negative 1 plus 4 plus 2, which would be 5. From there, we just write our absolute minimum and max. Let me rewrite that in red so we can see our answer. So we would have absolute max at negative 2 comma 6, because as we can see the y value of negative 2 is higher than negative 3, which were, and negative 1, which are right here. This is basically negative 3 and negative 1, and this is basically negative 2. We see, and this is at 6. So we see that it's the highest at negative 2 comma 6, and we see that it has an absolute min at negative 3 comma 5 and at negative 1 comma 5. And then yeah, that's all you really need. So now we're gonna move on to number 17. So number 17. So number 17, we are given y is equal, and then x squared over 2 plus 3x plus 5 over 2 with intervals of negative 1 comma 1. So first we find the derivative. This is going to be x plus 3, and then set it equal to 0. It's going to be x is equal to negative 3. So that's one of our critical points. However, unless I did something wrong here, x plus 3. Okay, but as we could see, negative 3 isn't, yeah, negative 3 isn't in this interval, so we're not even gonna like count it, because just for like a better explanation, let me draw that a little bit better. Okay, so let's say we're given this really weird graph, just however it looks, right? And let's say from negative 1, which would be like right here, and 1. We are not looking at anything past these two, so just inside this region right here, all of this region, this little line right here, even though this wouldn't be okay, anyways, this is all we're looking at, and since we got a critical number at negative 3, we do not care about this spot. We do not care about it, so we're not gonna put it in there. I'll just leave that there so you could process it. So we'll just put the table right here. So then we will have our intervals, our numbers, and our sign. So we have negative 1 to, I believe it's just 1. I haven't done this, so we'll see how it turns out. So from there, we are going to find a number, which would be 0. And then the sign that would give us is a positive. So, um, hmm. Yeah, since it wouldn't, yeah, since we don't have like a relative max or min, um, yeah, I'm not sure how, let's figure this out together. Um, because if we were to plug in negative 3 to negative 1, unless you still plug it in, But we wouldn't want that. I mean, let's try it really quick. -3 to -1, -1 to 1. And right there. Number would be -2, it would be half. So it would go, but we wouldn't, so we were plugging -2, it would go from plus, and then it would go to plus. Yeah, it would just be increasing either way. Okay, so from here, it's a really, weird way to see it. Because no matter what we put, unless I wrote the equation wrong. No, I wrote it right. So somehow in this one, it's stating that the absolute min is -1. Okay, I see. So if we have -1 to 1, it wouldn't matter what we put in because we're gonna get a, so it doesn't matter what number, but if you want to put 0, you're gonna get a plus. That means that this is gonna go up like this, which automatically means that if we're looking at an interval like right here, like let's say this is the graph and we're only looking from -1 to 1, it's going like this in this interval from -1 to 1. So this would obviously be the lowest point in just this section. It could be like really weird. It could go like that and then like, no, not like that. That wouldn't consider it a function, but like that. So right here, this would be counted. Let me write it in red. This would be counted as the min, and this would be counted as the max, because in this interval, that's the highest and lowest point. So from there, we know that the -1 is right here, and 1 is right here. So when we plug in -1 to the equation, we plug in and we go back and we plug in -1, we are going to get half minus 3. So the half can add to the 5/2, which would be 3, and we would get 0. And then you plug in 1, and you would get the 3, 6. You would get 1,6. Yeah. So then your absolute, let me rewrite this and let me erase this. I'm gonna make it that small. And then let's rewrite this. So the our absolute max would be at 1, comma 6, and our absolute min would be at -1, comma 0. Sorry for the struggle on that one. I do these problems with you guys on the spot, so if I ever pause on anything, I will not cut it out so we can both figure it out together. So for number 18, we get y is equal to x squared over 2 minus 2x, a nice and simple small one, to 4. So then our derivative would be x minus 2, and x would be equal to 2. So if it's in this interval, which is pretty nice, so then we write it, and then we get our interval, we get our number, and then we get our sign. So then we get 0 to 2. and then we get 2 to 4. So this is going to be nice because we're not going to get a fraction. So 1 and 3, and we plug it in. 1, you're going to get a negative, and at 3, you're going to get a positive, so it's going to go negative, then back up. So then at 2, we have a relative min. So then when we plug in f of 0, plug in f of 2, plug in f of 4, so that means 0 and 4 should be our maxes, 2 should be our min. So when we plug in 0 to the original equation, we're going to get 0 over 2, which is just 0. Then minus 0, so it's going to be 0 comma 0. Then when we plug in 2, we're going to get 4 over 2, which is 2. Then minus 4, so it's going to be 2 minus 4, which is going to be negative 2. And if we plug in 4, it's going to be 16 over 2, which is 8. And 4 times 2 is 8, so 8 minus 8 would be 0, so it would be 4 comma 0. And then, so our absolute, I forgot, we're supposed to be writing in red. Our absolute max would be at 0 comma 0 and 4 comma 0. And then our absolute min would be at 2 comma negative 2. Pretty simple. Number 19. We have just 2 more problems after this. Number 19. So we have, for number 19, we have y is equal to x squared, and we just have from the interval of negative 2 to 1. So we're going to find the derivative once again. You know, it's a repeating pattern, but it's okay. So that's our thing, and set it equal to 0, and you get x is equal to 0, which is between this. So we're gonna make our chart like always. We're gonna name this interval our number and our sign. Gotta be enthusiastic for you guys, or else this would be boring. So negative 2, and then to 0, and then you plug in 0 to 1, and then you get negative 1, and right here you can plug in half. So when we plug in negative 1, we would get a negative, and when we plug in half, we would get a positive, which means at 0 it would go negative and go like that, which means at 0 we have a relative min. Sorry for my bad handwriting. So now we want to figure out what happens when we plug in f of negative 2 and f of 0 and then f of 1. So then we see that was terrible. So negative 2, plug into the original equation, you get 4. You plug in 0, you get 0. You plug in 1, and you get, oh wow, we get completely different. We get completely different answers. Wow. Okay. So that means our min would be at 0 and our max would be at 4 only. Yeah. So what this basically means is that if we're looking at a graph, at x of 0, it is right here. So at 0, for this one right here, we have 0 right here. And for 1, at x is 1, it is at 1. And negative 2, which is over here, it would be at 4. So it would look something like this. Oh, not that little extra part. It would just stop like right there. Yeah. And it would stop right there. So our absolute min is right there, and our absolute max is right here, and our min is right here. So That means our absolute max. Let me bring this closer to me. This is getting kind of hard to draw. There we go. That's way better. Is at 0. Sorry, it's at -2. -2 comma 4. And our absolute min is at 0 comma 0. Check our answers, and that is right. One last problem. Just need one last problem. So number 20. Okay, so for number 20, we are given y is equal to x squared minus 4x minus 1. And we have -1 to 2. Okay, so we find the derivative first, like always. 2x minus 4. You set it equal to 0, and you would get x is equal to 2. So that's our critical point. Critical point is right on the interval, so we don't have to write like 2 comma 2. That'd be just the same point. There'd be no point in doing that. So basically, if we were to write a graph, this is basically what we got. So at some weird looking graph, this is 2 and this is -1. The x is equal to 2. We basically got it right on the interval. So we're just going to write -1 to 2. So then interval, our number, then our sign. And then from here, we're going to plug in a number. Could be 0, and you put it in the derivative, and you would get a negative. So that means during this interval, it would be going like this. So during the interval of -1 and 2, it's just going like this, which means at 2 it would be the lowest point, and at -1 it would be the highest. So that means that our absolute min, that's like a quadruple B right there, absolute min is at, well, actually I forgot to plug it in. We could plug it in with red. -1 and then f of 2. Did I do that for the last problem? Yes, we did. Okay. So f of -1. So then when we plug in -1, we would get 1 plus 4, which is 5, minus 1, which would be at 4. Then we do 2, and we get 4 minus 8, which would be -4. -4 minus 1 is -5. Let me double check our answer. And that is exactly correct. So our absolute minimum, so we see that the lower number is the 4, so our absolute minimum would be at sorry, our lower number is -5. I just saw the 5 and the 4, I didn't see the negative. Our minimum would be 2 comma -5, and our absolute max is at -1 comma 4, which is all. Thank you for watching the video.